Just right. Okay. My name is Keisuke Mori from NTT Japan. My company pretty much uses the pacemaker and postgresql for high availability cluster, and I'm also working with Andrew, who is a key developer of pacemaker for maintenance of a stable version of release 1.0 series. And today's topic is about integration with pacemaker and PostgreSQL 9.1. And now the recent version of PostgreSQL supports streaming replication. As of 9.0, it supports asynchronous mode, and as of 9.1 released last September, supports a synchronous mode, which is very important for high availability cluster. And to using a real production system, we need integration with high availability cluster software such as pacemaker for automatic failover. So my talk today is for enhancement of the resource agent, which is glue between the HA cluster and the application script. So we have enhancement of the script. So, again, what we did is, this is already existing active standby configuration. It's pretty simple and typical usage. There are two physical nodes, both running pacemaker running on them, and on the active node, PostgreSQL database is running, and pacemaker start up the PostgreSQL database through the resource agent script. And when active node failed, pacemaker detected and start on the standby node. And the data is on the shared storage, right? This is a very typical active standby configuration. Then now we have a replication feature. In that case, PostgreSQL database runs on both nodes, and on the one node runs as a primary status. And the other node, it runs as a hot standby status. That terminology is in the PostgreSQL status. And the data written to the primary data is immediately sent to the hot standby status. And both nodes write its own disk, so there's no longer shared storage. And the PostgreSQL runs two different status. So pacemaker needs to handle those two different statuses. So we need some additional features for the resource agent script. That's what we did. Okay. So why we want to do this? The benefit is, the first one is removing all single point of failure. The shared storage is sometimes a single point of failure. And second one, this is a really big difference, it's reducing the cost. Shared storage is usually very expensive. So you can build a shared storage much cheaply. And the another benefit is the downtime you can make it downtime shorter because when failover happened in active standby configuration, PostgreSQL database have to do a crash recovery on the standby node. That takes very long time. It depends, of course, depends on your database size or traffic, but it may up to 1 minute to 3 minutes or 5 minutes. That's a dominant part of the downtime. So we want to make it short. In the streaming replication, it's already there. It's ready to answer. So it's very fast. And another option is load balancing. The hot standby node can answer to the client. So you can also use a load balancing for read-only query. This is a simple comparison from other you may be familiar with the Slony one, but Slony one only supports asynchronous, so it's not usable for HA cluster. And PostgreSQL database is, of course, a database. So if you want to use other data than database, then DRBD is a very good solution for that. And another one is performance. The PostgreSQL is dedicated, optimized for database, so it's pretty good performance. The overhead should be less than 10%. Yes. Okay, so we enhanced the PostgreSQL resource agent script. The key difference is the The first, of course, it supports multi-state handling of the PostgreSQL database. Pacemaker already supports multi-state resources called master slave. So you can use our new resource agent as a master slave resource. And this new array also supports a kind of data protection. Suppose you two nodes. One node is right, but another node is data is corrupt. But if you run this node, the data is totally corrupt. But this resource agent try to make preventing a start if that data is it's all or inconsistent data. And when to make that PostgreSQL array create a kind of log file. So if you find this file, that node means the data may be outdated, there is some inconsistency there. So you can make sure what's wrong there. And also, crmmon is a monitor command for pacemaker, and this array displays a PostgreSQL status to what's running on, what's the status now. Without this, you have to look into the PostgreSQL log file or some type of SQL to get to know what's the running status. So the array displays on the crmmon command display to make it your operation easier. And another key is that if you run the two nodes at the same time, this array will detect which one is latest one. But as I described below, I don't recommend to use this. I recommend to use only single node invocation for that makes your operation more simple. This is a resource configuration of pacemaker. Usually pacemaker cluster requires a file system resource agent, IP address resource agent, but in this streaming replication, you only need a virtual IP. But you have to have at least two virtual IP on the primary side. One is for BIP master, is for answering a query from the client. And the other one is a BIP replication for replication for the PostgreSQL database. And optionally, if you want to have a load balancing for read-only query, you may want to have another IP address, BIP slave, on this standby side. If you don't need it, load balancing, you can remove this. The sample configuration of a pacemaker to build this is like this. The first line is creating master slave resources. And the bold lines are new configuration parameters. And the important one is rep mode, which enables this feature. If you remove this, it works as before, same as before. And you also need to specify the master IP address for here, for the replication link IP address here too. And another tricky parameter is stop on demode. I will describe what it means, but yes is recommended. So, and this is a sample of the virtual IPs configuration. There are three IPs here. BIP master, BIP replication, BIP slave, and some constraints here. Oops. This is a list of the new, all of the list of the new parameters in the new array, but you don't have to specify everything. And also, of course, you have to configure the PostgreSQL database itself to support streaming replication. This is only a part of the configuration that's related to the replication, but details for the PostgreSQL manual, it's already in there. But one thing you have to add is this include line. The resource agent creates this file to control a PostgreSQL status. So you need to add this line. Okay, and you launch the pacemaker, and it's a running status, actual running status as a replication. Look at the master slave display. So in this case, master is running on the node 1 and slave is running on node 2. And virtual IP is running on master and replication is running on node 1 and read-only VIP slave is running on node 2. And also you may see some attributes here. The PGSQL status means the current running status of database. And also it displays a PGSQL data status. That means what's the status of the data? Data is latest or old. Here's the list of the status, but you probably you will only see only part of them. Stop is obvious, and primary is obvious. And in a hot standby status, you may see a HS alone or HS sync. In a hot standby status, there are several different status in the PostgreSQL, but then you will see HS alone, which means the database is running on there, but not connected to the master side, so it's not static replication. And the HS sync means it's replicating and the data is already synced. So its replication is working completely. That's running status. And the data status means the disconnected means latest one is correct status. It's running as a primary and the data is up to date. This is a correct data. But the other node may be disconnected, means that node was once stopped, so and the master node is already running. So the failed node is the data is already it's too old, so it's not usable. So that node should not be a primary until you make it related. And when the master slave is running, it's streaming, but during the replication, it may not be up to date, so it's not ready to fail over. In that sense, in that state, it may streaming async. So streaming is working right, but not up to date. And also streaming sync is replicating and the data is synced. So in that case, it's ready to fail over. Anytime the fail occurred, the secondary node works as a primary. And okay, then there's how do you operate this? I would recommend this process. There are many choices or options, but I would recommend this one is a very simple one. So generally, I would recommend to run a pacemaker start one by one. Many users runs pacemaker on both nodes at the same time. But in this case, in this replication case, I don't think it's, I think it's very complicated. So you should start at the primary first, and then you should invoke a secondary node later. And before you starting the second node, you should always copy the data from the primary node to the hot standby node. To make sure that data is always correct. Because it's easily, there is a inconsistency. So you should always make sure that this data is correct. So here is an actual step-by-step based procedure. And first, you will initialize the database. And suppose the node 1 should be the first primary database. Then invoke the pacemaker and the resource agent on the node 1. And the node will get to the primary status of the database. And then you will copy the database from node 1 to node 2. You can use any backup command of PostgreSQL, like a base backup. This should be most simple one. PG base backup command will copy all the database from primary to secondary, primary to hot standby. But you may want to use a rsync or whatever. And then invoke the pacemaker on the hot standby second node. Then the hot standby node will try to connect to the primary node. And then when finish the replication, the status will go into the HS sync. That is already completed. So in that case, the both nodes are running correctly, and anytime primary node failed, then second hot standby node can promote it to the primary, so it can continue the service. And suppose, in that case, suppose the node 1 failed. In that case, node 2 is now primary. That's expected. And so how do you recover the failed node? There's a step for this. And first, you should stop the pacemaker on the failed node first and repair something wrong. And then invoke the pacemaker. But before invoke pacemaker, the node 1 is now going to a hot standby node, right? Then you should copy from the node 2, which is the primary, to the node 1, which is the hot standby. So copy database, and then in that case, the log file should be in the node 1. That means node 1 failed, and the RA intentionally leave that log file on the node 1 to prevent the node 1 starting alone. So you copy it from the primary, so you make sure that the data is correct. Then you remove the log file. Then pacemaker invoked. The pacemaker will start the postgresql on node 1 too. Then it should be go fine. And then node 1 is going to the HS sync status, and it is going to find the node 2 failed. Then node 2 will be primary again. Yep. Yes, that is how to use that. And from here, it's more implementation details. But probably I should talk to Andrew personally better. So, the problem is the state transition is different between pacemaker and postgresql. So there are some difference between the status. So the demo don't stop parameters change the behavior, but I would recommend yes. So I would skip to this, but skip up the details here. Okay, so last one is what's the status of the resource agent is we want to merge this resource agent for upstream official package of resource agent. So anybody who interested in this feature, please try and give a comment. The development code is available on the GitHub, and the developer is Mr. Takatoshi Matsuo, who is my colleague sitting next to me. He will answer your question or a comment. And document and sample I described above is also there. And please try and give us a comment. That's all from me today.
Please thank Mori-san. We're theoretically in break time, but that's what. Take some questions if anybody has any. Oh, silence. Here's a question.
If you've got a hot standby and you said the master files, the master files, the hot standby becomes the master, the master goes back to a slave or not? It just stops.
Just stop.
Just stops on that. Yes. Okay, cool.
Just wondering what like performance analysis you've done and what sort of the performance impact is versus.
In my slide, it's just use a page bench, simple page bench. It's read and write.
Yeah. I doing like typically I see like with a two-phase or synchronous thing, you get a pretty big impact dependent on network latency. So it's just interesting how it works.
And it works.
Yeah.
Sorry, I don't have the details right now.
Okay.
I'm sorry.
One at the back.
In that scenario where you just described when the master stops and the slave gets upgraded, what happens if the master, if you bring it back online, does it automatically try and assume master status again, or does that, how do you configure that, or how does that side of things work?
I'm sorry, could you say that again, please?
So if your master crashes and you a slave gets upgraded to master status, if you get your master back online again, does it automatically assume master status, and the slave that got upgraded, does it then go back to being a slave?
Not automatic. It should be done manually.
I was wondering how your software determines that the data in one of the two is too corrupt or is unable to be used or depended upon, so that you say that Postgres won't start on if the status is bad. I was just wondering how your software determines that the status is insufficiently good.
In our RS logic, if there is one master node and the other node is down, then other node should be rate replicated, so it's already invalidate the data.
Sorry, I didn't quite catch. I didn't understand. I'm sorry. My hearing's not so
sorry,
good.
My English is bad. So, could you take by person? It's better for me to understand your question too. So, please talk to one by one. Personally?
Yeah.
Later. Yeah.
I'll give you the last one.
Well, simple question. What happens after a power failure?
Power failure?
Yeah, both nodes reboot at the same time. What happens?
Then you should have another solution like a disaster recovery solution like this. Yeah, if you there's the same rack, then we cannot save that.
Can they discover that they're both up and talk to each other again, or does it require agreement? If both nodes reboot, can it automatically come back alive?
Not automatically. You should always make sure by manually.
Okay, let's stop it there. Please thank Mori-san again.